Hi everyone, this video is the first of 3 videos to go over the semester exam review. We'll be taking it 6 weeks by 6 weeks. So let's jump right into it with problem number 1. It asks us to write an equation in slope-intercept form. And slope-intercept form is y equals mx plus b, where m is our slope and b is the y-intercept. So looking at my graph, I can see that my y-intercept is at 1. So that means that my b value is equal to 1. Now I want to determine what my slope is. And so in order to do that, I am going to start at my y-intercept and see where I have to go, how far I have to go down before I land on another nice point on our graph. And I can see that I'm going to land on a point right there. And so we have gone down 2 squares and over 1, 2, 3 squares. So down 2, negative 2, and over to the right by 3. So our slope is negative 2 over 3. That means that I can write my equation as y is equal to negative 2 over 3x plus 1. Problem number 2 asks us to use linear regression feature on Desmos to find an equation of the line of best fit for the data. So the first thing I want to do is go ahead and determine what my x and y points that I'm going to put into this table are going to be. So reading off the graph, I see that at an x value of 1, I'm at a y of 4, 2, 6, 3, and 7, 4, and 12. I'm going to use this table in Desmos and add the table items to the x1 and y1 values in a table that I create. And then because I want to do a linear regression, I'm going to write this in my second line so that Desmos will give me a value for m and for b. So let's take a look at this in Desmos. Once you're over here in Desmos, you're going to select the plus button and hit table. We have x1 and y1, and we're going to put in our values. We have 1, 2, 3, and 4. And then for our y values, we have 4, 6, 7, and 12. You can hit the little zoom at the bottom of this square right there, and it will zoom in on your data so that you can see it well. And now I can see all 4 points. The next thing that I want to do is go ahead and write my equation. It's basically the equation of a line, y equals mx plus b, like we saw in problem 1, except we need to use this Desmos special notation. So we're going to use y1 and x1, and we'll use the approximation symbol instead of an equals to indicate that we want Desmos to find the values of m and b for us. So we will put in y is approximately equal to mx1. Actually, I forgot the 1 on my y, so I'm going to fix that. mx1 plus b. And now we've got our parameters that we need. We have an m value of 2.5 and we have a b value of 1. Let's go back over to our review and put those values in. Here we are back in our review. Remember, we're writing our equation as y equals mx plus b, and we determined that m was 2.5 and b was 1, giving us y is equal to 2.5x plus 1 as our final answer. Now let's go ahead and look at solving some absolute value equations. The one thing that you need to remember about absolute value equations is that there are 2 solutions. One where we write everything we see in the problem, but without the absolute value bars. And then the second one where we write everything again, but we add a negative sign on the right-hand side. So let's take a look. I also want to just give you a quick heads up that as you watch this video, you may notice that some of the previous problems in the video, if you kind of look above where I'm working, might look different than the ones on your review. And that's okay. We made some adjustments to the review this year, and so I have gone in and edited out the portions that we didn't need anymore and put in portions like this that we do need. So we have x plus 10 is equal to 2, or x plus 10 is equal to negative 2, and we solve both of these by subtracting 10 from both sides. So x is equal to -8. These are single point answers on a number line, if you wanted to draw that. And subtracting 10 from both sides here, we get x is equal to -12. And those are our two separate answers. We'll start problem number 4 the same way. I'm going to split into two equations. One where I write x over 4 is equal to 8. Remember, just removing the absolute value bars. And the other one where I write x over 4 is equal to -8. And I want to solve both of those. So right now, I have x divided by 4. In order to move the 4 to the other side to solve for x, I need to multiply by 4 so that the 4's will cancel. But if I do that on one side, I have to do it on the other side. Remember, you have to keep equations in balance. So x is equal to 32. For the other one, we need to do the same thing. I want to eliminate a 4 in the denominator of a fraction. So in order to eliminate it in the denominator, I need to have a 4 on the top where I'm multiplying. So those will cancel, and I'm again multiplying by 4 here. X is equal to -32. The next couple problems have to do with transformations. This first one, we're given a description of a transformation, and we want to write our final g of x. So the first thing we have is 3 units to the left. Second thing is 2 units to the right. So number 1, I'm going to call this h of x, kind of an intermediate step. Left is inside with x. So in this case, that means inside absolute value bars. And whenever we're inside, because we are doing a horizontal transformation, we have to think opposite. So instead of an x minus 3, it's an x plus 3 because of the negative sign in the transformation equation. Secondly, we're going to say g of x, our final, is equal to starting with our h of x and doing a vertical translation because we're 5 units up. Vertical things happen on the outside of absolute value bars or parentheses, and no opposite things to think about. So we just add 5. And this is our final answer. All right. Number 6, we're kind of doing the opposite thing. We're given an equation and we want to identify the things that have happened to it. We also want to identify the parent function. Over here in this little cloud, I kind of gave you some reminders on how to find which parent function it is. Notice that we have an x plus 2, but it has an x in it and it's squared, so we're quadratic. And then we want to identify what's different from just our y is equal to x squared parent function. So I notice a 4/3, a plus 2 on the inside, and minus 7 on the outside. Those locations are important. 4/3 on the outside means it's something vertical. It's a stretch because 4/3 is going to be bigger than 1, so it's a vertical stretch. Not a shrink, but a stretch. Inside we have a plus 2, and so that's moving us to the left by 2. Again, remembering horizontal and inside is opposite. And then finally a -7 is a vertical transformation, so it's on the outside. That's how I know it's vertical. And I want to move down by 7. So vertical stretch by 4/3, left 2, down 7. All right, this next one we want to write the numbers in interval notation. We want to remember a couple things. First, interval notation is parentheses or brackets enclosing our numbers, and the numbers themselves are listed in order, smallest, comma, biggest. So our smallest number in this inequality is -75. Our biggest number is 23. The -75 has a less than symbol, which relates to a parentheses based on our little smiley face, and the 23 has a bracket based on the less than or equal to. This is our final answer. All right, number 8, find the domain and range for the given graph in interval notation. It's a parabola. For a parabola, remember that the domain is always all real numbers, which written in interval notation looks like this. So domain, remember all 3 functions that we've talked about this semester, linear, absolute value, and quadratic, always have a domain of negative infinity to positive infinity, or all real numbers. All right, range is going to have to do with whether we have a maximum or minimum point and where it's at. So we have a minimum point here. So that's going to be the low end or the smallest number of our range at a y value of 3. Remember, when we're looking at a point on a graph, it's included. So we're looking at bracket. And then our arrows are pointing up, so we're going towards infinity. So domain and range are given here in interval notation. Set builder notation. This is the one with kind of the fancy, what we call a brace. If you can't draw a brace, it's okay to just kind of do a squiggly vertical line. I'm okay with that. All right, so x and our bar means all real numbers x such that, so we're starting with real numbers, but we need to restrict them to between -8 and 5. Between is a critical word here because between means it does not include the points. It's everything between them, but it's not including them. So does not include the points. After we've done our fancy little start, it basically just boils down to doing inequality notation. X is somewhere between -8 and 5. So -8 is less than x, but x is less than 5. And that is our answer. All right, number 10, last one. The table shows the number of ice cream cones sold for different outside temperatures. We want to determine if we have a linear relationship. We want to find the equation and tell whether it's a strong or weak relationship. So 3 things to determine. Remember that a strong linear relationship is greater than 0.7, tops out at 1, and a strong negative linear relationship would have an R value or a correlation coefficient less than -0.7 between there and 1. We are back over in Desmos, and I used the same steps that I used in problem number 2 here. I created a table and I wrote y1 is approximately equal to mx1 plus b. Don't forget that you want to zoom your data in so that you can see all of your data points and really get a good look for your line. Now we need to answer some questions over in our review. One of those questions was, does this show a linear relationship? Well, looking at the line that's going through the data, we can see that all of those data points are very close to the line. And so this is definitely a linear relationship. We have an R value of 0.997. That is very, very close to 1. And remember that R values top out at 1. And so this is definitely a strong linear relationship, and in fact a strong positive linear relationship. We can also pull our M and B values here, M of 1.48 and B of 12.09. So based on this, we'll go back to our review and write what we've just seen here. All right, so linear relationship, yes, definitely. Our equation is y equals ax plus b, 1.48 x plus 12.09. And is it a strong relationship? Well, with an R value of about 0.997, yes, it is strong. This concludes this video. Please continue on to the second video to see 6 weeks number 2.